Welcome back to the Deep Dive. Today, we're plugging directly into a really significant technical shift coming out of XAI. If you've been working with the latest large language models, you probably know the feeling, right? They've gotten incredibly smart over the past year or so. But that intelligence, well, it often comes with a catch: latency. Things just feel slower.
It's been the classic trade-off, hasn't it? You want that deep, complex reasoning. It means more compute steps, and more steps means higher latency, and frankly, much higher operational costs. But what we're looking at now with xAI's Grok 4 fast model, it seems like a genuine attempt to, well, break that link.
Exactly. And this isn't just, a slightly stripped down or cheaper version. They're positioning it very clearly as a speed-first sibling to their main Grok 4 model, built from the ground up, it seems, for speed, for those rapid interactions, coding assistance, real-time stuff.
Yeah, and our mission today for you listening, especially if you're technically focused, is to really unpack this. We want to get past the marketing claims, look under the hood at the architecture, the performance numbers, figure out where speed really meets capability here, and what it actually means for developers, trying to scale things effectively.
Right. So let's state the main idea right at the start. Grok 4 Fast feels like a very deliberate engineering compromise. Maybe compromise isn't even the right word. Perhaps optimization is better. It's not aiming to replace the deep thinking of the bigger Grok 4. It's all about throughput, keeping things moving in those daily workflows. Because let's dig into the structure first. A big change with Grok 4 is this explicit multi-mode setup. You've got fast, standard, and then this Grok 4 heavy, which is focused purely on capability. It feels like the first time we're seeing this speed capability cost spectrum laid out so clearly within one model family.
It is quite explicit. And that differentiation, it's made possible by a really fundamental technical change underneath. See, older Grok versions or even other models might use different actual models for different jobs, like one for reasoning, one for just generating text quickly. Grok 4 Fast, instead, uses what they're calling a unified weight space.
Unified weight space. Okay, that sounds technical. What does that actually mean for someone building with it? Why is that such a key point?
Well, think of it like this. Instead of having, say, two completely separate engines you need to switch between depending on the task, you have one really high-performance engine. The unified weight space means the core knowledge, the underlying weights are the same. But you can steer its behavior almost instantly just using system prompts. The prompt basically tells the model, okay, for this one, use the fast pathway, or nope, this needs the full multi-pass reasoning, activate heavy.
Ah, I see. So the prompt isn't just telling it what to answer, it's actually directing how it computes the answer.
Yeah.
Which internal path to take.
Precisely. You avoid the overhead, the latency penalty, of loading a whole different model or switching modes in a more cumbersome way. And for fast mode, this steering mechanism forces it to prioritize that quick turnaround. It simplifies or limits some of the deeper internal reasoning loops. It actively avoids those computationally expensive cycles unless the prompt really demands it. It's all about minimizing the compute needed for each individual call.
That makes sense for speed, definitely. But usually, less computation means, well, dumber results, right? Yet, they're claiming this model keeps top-tier performance while cutting down that internal work. Which brings us to this concept they're pushing: intelligence density.
That's the term they're using, and it's key. Intelligence density means getting similar output quality on tough benchmarks, but using significantly fewer inference tokens to do it. The claim is that Grok 4 Fast uses roughly 40% fewer inference tokens. Those are the internal thinking tokens compared to the standard Grok 4 for similar tasks.
Wow, 40% fewer thinking steps for a comparable result.
Yeah.
That's a serious gain in efficiency. It's almost like having a processor that runs the same software but generates 40% less heat.
Exactly, and it completely changes the economics. If you can just chop out 40% of the internal processing, especially for things you do a lot of, like quick summaries or generating simple code snippets, you're fundamentally altering the cost structure of your application. That efficiency is really the foundation for the cost savings we'll get to later.
Okay, let's tackle those headline numbers. We see things like up to 10x faster responses. Now, up to always makes me raise an eyebrow. That 10x figure, where's the asterisk? What's the real story there?
You're right to be cautious. That 10x isn't an average speed up across the board. It comes from very specific controlled micro benchmarks. Think really short, predictable tasks, like super fast API calls, maybe looking up a single fact or completing one line of code. These are tasks where the standard model might have a bit more setup overhead or do extra reasoning passes it doesn't strictly need, making the fast model look disproportionately faster in comparison.
Okay, that's important context. So it's more about slashing the startup costs for quick jobs, not necessarily making a 3-hour analysis finish in 18 minutes. Still, the raw numbers they're reporting for responsiveness are pretty impressive on their own. Sustained throughput of 285.5 tokens per second.
Yes, and maybe even more critical for that feeling of responsiveness, particularly in interactive scenarios, is the time to first token, the TTFT. They're reporting 0.51 seconds, just over half a second.
Half a sec. Yeah, think about that if you're a developer just wanting a quick code suggestion. That incredibly low friction. It could genuinely change the calculation of whether you wait for the AI or just type it yourself. It keeps you in the flow.
Absolutely, it enables that high momentum workflow. But we do need to talk about the reasoning trade-offs. The reports are pretty clear. For short-form reasoning, summarizing a short document, comparing two things quickly, fast is apparently very skewing. But if you're asking it to do deep synthesis, like write a 5,000-word analysis, drawing novel conclusions from complex data, well, the standard or heavy modes are probably still going to give you more depth and rigor.
Right. It's like the difference between a quick brainstorming partner and the colleague you trust to write the final detailed report. What's kind of surprising, though, is that even with this intentional streamlining for speed, its performance on standard benchmarks seems to remain right up there. They're reporting scores like 92.0% on ARME 2025 and 93.3% on HMMT 2025. These are tough math reasoning benchmarks.
That does raise the question, doesn't it? How does a supposedly fast model, one that's cutting computational corners, still score so well on complex reasoning tests? The likely answer lies in how it was trained. It seems it wasn't just trained to think harder internally. A key part was end-to-end training with tool use reinforcement learning.
Ah, okay. So it learned not just to calculate everything itself, but to figure out when it needs outside help, like a search engine or a calculator, and how to use that tool effectively and quickly.
Exactly. It's been optimized for that kind of agentic behavior, knowing when not to brute force the answer internally. And this shows up in specific benchmarks. Its search-focused variant, apparently codenamed Menlo, is ranked #1 in El-Arena's search arena with a high ELO score. You see real gains on benchmarks testing interaction. BrowseComp at 44.9%, SimpleQA at 95.0%. It's good at efficiently deciding if it needs a tool and how to use it, which is inherently faster than trying to derive everything from scratch.
Okay, so that technical efficiency, the tool use,
Yeah.
it all seems to point very strongly towards one killer application, not coding. For the typical developer, this speed-first approach seems tailor-made for that constant back and forth of writing, testing, refactoring code.
And the feedback coming from the developer community seems to really back this up. We're hearing about specific strengths. Rapid refactoring is one. It gives you clear code diffs with concise explanations almost instantly. It's also reportedly strong at bug triage, helping pinpoint where things are going wrong pretty efficiently. And it seems fluent in the common web stacks, Node and React, Python with FastAPI, Flask, Django. You know, when you hit a coding problem, getting immediate feedback, even if it's just a good starting point, is often way more valuable than slightly more perfect advice that takes 30 seconds longer.
Yeah, that immediacy is key. And it's interesting how people are actually using it day to day. It sounds like they're not necessarily replacing their primary AI coding assistant, but using Grok 4 Fast alongside others, pitting it against models like Sonnet 4 or Gemini 2.5, maybe even the upcoming GPT-5, using it as a second opinion generator, or specifically tapping into it when they need a less generic, maybe more creative suggestion. It acts as an accelerator.
That second opinion idea, or what you might call hybrid routing, seems like a really practical workflow emerging. Because it's so fast, some developers are apparently asking it for both a quick fix for right now and maybe a more robust solution for later, getting both perspectives almost simultaneously. It really leans into its speed. And community comments seem to confirm this, people saying it's super eager to code or even trigger happy, sometimes skipping the chatty part and just immediately generating code.
Huh. That trigger-happy description, that's the speed optimization showing itself in practice. Now, beyond just generating code snippets, we have to touch on its memory capacity. That 2 million token context window, that's not just a bigger buffer. That fundamentally changes how you can interact with large amounts of information, right?
Oh, absolutely transformative, especially for tasks involving deep analysis of long documents. With a 2M token window, you can potentially feed it incredibly long texts, think entire technical manuals, massive legal contracts, research papers in a single go. Developers don't have to mess around with complex chunking strategies or setting up separate retrieval augmented generation or RA pipelines just to handle the size.
You potentially bypass a lot of that complex RE engineering overhead, which saves development time and compute time during inference.
Exactly. And we're seeing concrete examples mentioned. Financial firms using it to analyze huge SEC filings, for instance. The ability to load, say, 3 gigabytes of text, entire sections of a filing into one session for immediate, comprehensive analysis that can drastically reduce the time needed for manual review. It speeds up things like risk identification or checking for compliance issues across a massive document.
And that connection from technical efficiency in handling large context to real-world financial impact seems pretty direct here. Because of those architectural choices, that 40% token reduction you mentioned, combined with what looks like very aggressive API pricing, XAI is making a pretty staggering claim, something like a 98% reduction in price to match the performance of the standard Grok 4 and some of those high-end benchmarks. I mean, 98%, that sounds almost too good to be true. Is that realistic outside a lab?
Well, that 98% figure is definitely the headline grabber. It's crucial to understand. It bundles together a few things. First, the higher intelligence density, meaning fewer internal steps needed. Second, the lower overall compute requirements that result. And third, yes, deliberately aggressive pricing. It's the combination of those three that allows them to make that claim. It represents a potential fundamental shift in the cost-to-capability ratio, especially for businesses running AI at scale.
Okay, let's break down that pricing structure then. What are developers actually looking at paying?
So for the standard low context scenario inputs under 128,000 tokens, the price is listed as $0.20 per 1 million input tokens. Output tokens cost a bit more at $0.50 per 1 million output tokens. But here's an interesting detail that encourages smart architecture. Cached input tokens are significantly cheaper, around 0.05 per million.
Okay, so that price difference between fresh input and cached input, that's a direct financial incentive for engineering teams. It pushes them to be really smart about managing recurring context in conversations or multi-step processes. Reusing context saves them 75% on that part of the cost.
Precisely. And when you combine this pricing with the speed benefits we discussed, you start to see compelling financial case studies emerge. Quantex Capital, for example, was mentioned as reporting a 40% cut in manual review time for those big SEC filings. For a mid-sized financial team, that translated into an estimated $1 million in annual savings. Reducing latency isn't just nice to have, it can have a direct, significant dollar impact.
And that financial pressure naturally leads development teams towards certain architectural patterns. Yeah. Like actively routing those high-volume, short, often simple queries, which are usually the majority of requests straight to the fast mode. That alone could dramatically cut the overall compute bill for an organization.
Definitely. And this growing demand for high-speed, low-latency inference isn't just impacting model providers like XAI, it's creating huge opportunities for the hardware companies, too. You look at Grok, spelled G-R-O-Q, they raised something like $750 million in 2025. Why? Specifically to build out infrastructure to meet this surging demand for fast inference. They position themselves as enabling models like Grok 4 Fast, so the focus on speed ripples through the entire ecosystem, right down to the silicon. #outro.
So wrapping this all up, what's the core takeaway for you, the practitioner or architect designing systems with these models? Grok 4 Fast isn't trying to be the deepest thinker on the block. It's optimized for momentum. It's built for speed and those daily iterative tasks, coding, quick analysis, anything where getting a high-quality answer right now is paramount.
And based on that, our practical advice has to be, don't just rely on the generic benchmarks. Test it rigorously against your specific real-world prompts. And start thinking about hybrid routing strategies now. It seems almost essential. Funnel those quick, frequent requests to fast mode, but consciously reserve the standard or heavy modes for tasks where you absolutely need maximum depth and rigor. Knowing when to switch is key.
That hybrid approach really does feel like the future for deploying these powerful models effectively and affordably. We're moving past the idea of one single model doing everything. Which leads to a final thought for you to consider. If this kind of mode-aware routing, dynamically choosing between fast and standard heavy based on the request, becomes standard practice, what new challenges does that create for system architecture? How do you build applications that can seamlessly integrate and manage these different modes within a single user experience or workflow loop? That need for smarter, context-aware routing layers feels like the next big engineering puzzle for developers working in this space. Definitely something to mull over as you optimize your own systems.
Absolutely. And solving that puzzle is going to demand some real cleverness in prompt design and managing those different latency profiles effectively.
Well, that brings us to the end of this deep dive. To stay updated on the latest in AI and ML, don't forget to visit our webpage, neuralintel.org, and you can also find us on YouTube. Thanks so much for tuning in.